Okay. Just to quickly review where we were last time, we were talking about functions, then we started talking about instance methods, right? Remember how like in Python, you would have self would need to be there for the method, and then if you called, like here I'm updating some value of an attribute, so it belongs to the class, so I need self. In Java, I don't need that, but I could say this dot, it would mean the same thing, but I definitely don't put it in here in the parameter list. And then we talked about the visibility modifiers, public and private. In Python, there were only conventions. This would mean like here's a function or a method, just don't use it though. You can use it inside the class, but don't use it from outside the class. Here, we can actually say private and public. That would actually enforce whether or not you can access that thing. And then really quickly, here's that Celsius to Fahrenheit function that we used several times in 161. The one big key difference here is the division. By default, and this is, if you don't like this, you're wrong. You should like this. The default behavior in Java is if you are dividing two integers, you get back an integer. It makes sense from a type perspective. If you want, but of course, if you're dividing 5 by 9, the answer is 0. Now you're all left going like, well, no, it's 0.55555. Well, yeah, but we have an integer, and you can't put 0.5555 into an integer. If you really want floating point division, well, then make sure you're dividing floats. Yeah.
So is there a particular rounding method? Like, does it round to the nearest, or does it just round down?
It does what we call truncating. It could be 0.9999999999999. You get 0. It doesn't round, it truncates. You just lose the decimal. Okay. Python used to work like this, and then they changed it and made everyone mad. To this day, I'm still left. Python bros will try so hard to explain why it makes more sense. No, they're trying too hard. Comments in Java. In Python, you use like the number sign. In Java, you use //. You don't need the space, but common to have like // space, then you type your comment. When you see things that are like // and there's no space, usually that means like a line of code was commented out, but it's not a comment that means anything. So this is a single line comment. Here's a multiple line comment, right? /*/. You can open, close. Remember how you did that in Python? You would do that with like multiple quotes. And then finally, there's this style, which is like the Java doc style commenting. Remember how in Python you would always put a very special important comment at the beginning of all your functions? Now, in Python, you would always put it like here, right? But after the declaration line, but before all your code. In Java, it goes just before everything. And it follows the same format as before. Describe what's going on, and then, at param. Here we need the at whatever. You describe what all the stuff is. One sec. The format of this is actually very important because you can generate your Java docs. Basically, your documentation would be based on this. In fact, like if we go, like first of all, like if I go to object.equals, you go here, of course there's, yeah. Now this is rich text format style, but like, see, like it's following that same format. It's using some special syntax that we don't need to worry about, but it follows that same format. And if we go and look at it's in the equals. It's not worrying, okay. Java equals. So I want the actual objects class. So this is like the official documentation. And it might not match exactly here, but let's see. Equals. Returns true if all the arguments are equal to each other and false. Otherwise, consequently, if both arguments are null, true is returned, blah, 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 blah. Okay, let's see if it does match. Returns true if the arguments are equal. Look, it's generated, like this generated that website. So like you comment these things properly, and then you get perfect documentation for your code. It's wonderful. So much so that it's like literally on Oracle's website. Oracle like made, well, Sun, but Oracle owns Java. Yeah.
How do you open the?
Like the link?
Yeah.
I control click. It's kind of neat. You had a question too?
Yeah, I was just wondering wondering what with the second asterisk after the first slash.
You mean here? That's just so it designates, that's the syntax for like, oh, we've got a Java doc thing here. Now, if you don't have that second one, it'll still look like this, but it won't really be a Java doc. It's for parsing. That's all. Cool. Other questions, thoughts, concerns, comments? Comments? All right, yeah. And the at param, at return, they are important. You would have one for each of your parameters here. We only have one. Yeah. Booleans. So, any questions so far? So Booleans work the same way in Java as they do in Python, except in Java, we use lowercase t. That's actually normal. Python was the weird one. Lowercase t, lowercase f, okay? And if we wanted to make a variable for it, well, we say Boolean. Boolean for Boolean type, okay? All of the ands, ors, nots, and all that work the same way, except instead of typing and typing or, we use different symbols, but we'll see that in a moment. So here's conditions with Booleans. Here's an if and an else, right? So if some Boolean, right, because that could be storing true or false, whatever. But if true, we run it was true, otherwise it was false. Here's how you would write it in Java. These parentheses here are important. The expression that is like the Boolean expression, now here it's only a value, but this could be like some Boolean or some other Boolean, whatever. Whatever the expression is in the parentheses, and then open squiggle, close squiggle, else open squiggle, close squiggle, right? These don't need to be on the same line, but it's common to have them on the same line here. If I didn't have an else, that's fine. If you don't have like an exclusive or situation, you could just if close, right? The else is, you don't need the else. But there's conditions. And notice that each statement in the condition is ended with a semicolon, but the if isn't itself, because like this is the whole like if, right? Questions, thoughts, concerns, anything? Boolean operators. Well, you know, those comparison operators that we were used to in Python, where we're comparing things like numbers, let's say, they work as well, a less than b, but that'll give you back a Boolean, right? But, you know, lowercase t, lowercase f. Sameness, c equals d, not sameness, e not equal to f, that's how we do not equal. Cool? Yeah, these are the same. Logical operators, they work the same way, but the syntax is a little different. In Python, we'd said v and w, but here we say ampersand, ampersand. The ampersand means and. This is more common among the similar languages. And or is these pipe characters. If you're wondering where on earth is that, it's shift above your enter key on your keyboard, okay? That's where you find it. That means or. And not is exclamation mark. So instead of writing not, you say exclamation point. Those are the key differences there. There is, by the way, a difference between writing, I've talked about this before, I know I have, but I'm just going to type it here because this is good enough. Something and something else, no. Versus, oh, come on. These two lines have different meaning. The first one is and, okay? Though you're not often going to use that one, but that is the regular old and. Double and is a special and that allows you to use this, what we call like the annihilator property. It's called a short circuit and. What it means is something else. Imagine that's false. Do I care what's over there? No. So I don't even need to do the full evaluation. I can save some time. Now, you might say, I mean, how much time are you saving, right? You don't really need to do the operation. Well, something else, imagine that's like a function that returns a Boolean, right? So imagine that's a function that returns a Boolean, and this is a function that returns a Boolean. And this function over here that returns a Boolean is 1 billion lines long. If I don't need to run it, don't run it. Okay? So that's what ampersand ampersand means. It's the same thing with or, except with or, it's just kind of like flipped, right? If the first one's true, you don't need to evaluate the other side. Yeah?
How do you type that or on the keyboard?
It's shift the key above your enter. Everyone try it.
Why do the not lazy ones even exist then?
The not lazy, because side effects. Imagine you have a function.
I see how I see.
Yeah, so now if you're a good programmer who doesn't have side effects and everything's immutable, then, whatever, it doesn't matter. But it's entirely reasonable for there to be a situation where, like, imagine this function. If it's a pure function, remember, when I say pure function, I mean it takes some inputs, produces some output. An impure function is takes some input, produces some output, maybe it doesn't produce some output. Oh, and it messes up some code over there somewhere, which is, it happens all the time. Like, it's not uncommon. It's not necessarily, like, I would say that's not, don't code like that, but, sometimes it happens. Side effects, they're a thing. I see you, just one sec. If you have, like, 1 billion lines of code, but there are side effects in that code that are important, like check the status of the nuclear fuel rod or something, right? We might want it to run regardless, even if we know the result is false. So it gives us flexibility. You're right for wondering why, and that's why. Yeah?
I just didn't hear what the single ampersand
That's and. This is the short circuit and. This is if this is false, ignore it. If this is false, I still evaluate this side though. Yeah?
You can still write out and though?
No, that won't work. You need ampersand or ampersand ampersand. Yeah.
So you're telling me that if I have a really long code for the second one and I put a single ampersand, then I can use the time that my code's running to think about what I can do with the time I saved by not typing the second one.
If you want, yeah. There was another, yeah.
Where is it on the keyboard?
Which one? Ampersand?
Shift
7.
7.
If you have what I'm looking at, yeah. Other questions? If you have a French keyboard, it could be different. So I don't know. Anyone here accidentally change the format of their keyboard to like French, and then you get confused? Why is question mark, exclamation point or something? Yeah. It happens. Pardon? Yeah, that's... It's annoying when what you see is not what you get, right? Yeah.
I use my friend's French laptop.
And it throws you all off. You can't find anything. Yeah. All right, loops. Loops work just as you should expect in Java as they do in Python. So we're going to start with while loops. So here is a counting while loop. Why is it counting? Well, okay, look, here's the Python one. C starts at 0. Is C less than 10? C is now whatever. Add 1. Is C less than 10? And so on. C is just counting up, and it's going to run 10 times, right? 0 through 9. Here's the same code in Java. What's the difference? Well, the difference is we need the parentheses, just like with the if. Mind the fact there's no semicolon here. The semicolons are only for like the statements inside the loops. So while condition in parentheses, and in Python, colon indent, well, here we have open squiggle, close squiggle, in case whatever's there. I want to check something here. Yeah. And notice I'm using C++. Remember, that's like the shorthand for the shorthand. C++ means add 1. So I don't specify what I want to add, but plus means just add 1. So it's like a shorthand. Cool. Same idea though. Any questions about this? Everyone's happy? I'm going to keep emphasizing this. I know I have been. I'm going to keep doing it. I'm going to when we get to the end of the topic. I'm not telling you all this now for you to be like, I memorized this completely. I'm showing it to you so it's not unfamiliar, and that when the time comes to actually like do this, like you actually have to start writing in Java, like you've kind of seen it, but you know enough to be able to go figure it out on your own. Like if you need to go Google it, you'll be like, yeah, I saw something like that before. That's the level I'm happy with. Yeah.
What's up with in the Python string C?
because you can't add a string and an integer together. So we need to convert it to that there. I guess in Java, it's smart enough to know. We could, you mean here? We could have used an f string. Could we use an f string here? No, sad. Why? Because Java doesn't have f strings. Why not?
Bad.
Because it's evil and it hates you. Yes, that's why. That is the question Java programmers have been asking for a while. Okay, C++, yeah. Here is a while loop that's just using some other Boolean expression. Sure, the counting while loop was the same idea, right? Because the while loop really only checks some Boolean expression. There was nothing that really made it a counting while loop. It was just the fact that the Boolean expression cared about counting. Here it's like, okay, well, stop is false, C is 0. Well, not stop, C is now whatever, add 1. If C is ever equal to 5, set it to stop, right? It's a contrived example for the sake of showing you another example of a while loop. Here's the same thing in Java. Same idea. You know, we need our types though, parentheses, exclamation point instead of not. Other than that, yeah, that's basically it. Anything? Happy, sad? Happy, okay. Now, for each loops, the loops that you're used to, like the non-while loops that you're used to in Python, are more of what I would call a for each loop. It's a loop. It's a loop. But remember how like those loops were always like for each thing in a collection of things, right? Even when you used range, it really still was like a for each loop because range gave you this like, if I said range 10, it really kind of like gave you the list of 0 through 9. Right? And then, oh, now you're iterating for each thing in that list. Not literally give you the list. If it was Python 2, it would. Python 3 gives you like an iterable object or something like that. But the point is, those loops in Python were really like for each loops, for each thing in a collection of things. So we have those in Java. So here it is in Python. We have a list, A, B, C, D. For C in a list, print out C. Over there on the right, I've got a character array. Now you might say, character, oh, he's using that character thing. Okay, I guess it comes up more often. No, it doesn't. It really doesn't. I just used a character array here to be fancy. Because you never see it, so I thought, I'll use one. A character array, why is it a character array? Well, it says char, that means character, and the brace is there. The square brackets mean like array. If I didn't have that there, it would just mean in making an individual character. Oh, this means character array called an array. Yeah.
Can you index a string in Java?
Yep.
Okay,
Yeah.
so is that
It was
basically
kind of
just
the
a
same
string?
thing with a couple extra bells and whistles. A lot more bells and whistles actually. String objects have more to them than just an array of characters, but effectively, like at face value, same idea. And then here's the array A, B, C, D. Mind the fact that there's single quotes here. That's because they're characters. I'm just doing this for the sake of doing it with characters, not overly important. Now here is the syntax to do the same thing. So this C here, remember, it's just a variable that represents like the current thing in the collection of things. So first time through the loop, C is A, then B, then C, then D, right? Same idea here. But like everything in Java, all the variables, we have to specify the type. So what is the type of C? Well, it's going to be a character. Why? Well, because it's an array of characters that we're iterating over. So we've got this character C, and instead of writing in, we write colon. And then we write the collection of things. So this is the for each thing in the collection of things. For each thing C in the collection and array. Okay? And what are we doing? Printing out C. Cool? Happy, sad? If you're sad, tell me. I want to know. I want to make you happy. Yes?
How do you, how do I put this? Like, how do you put in the, I think it was the enumerate function?
Oh, enumerate. We don't have that like built in like that here. But you would just create like another counter to go along with it or something. Or you don't really, I'm going to be honest. I never use these. Very, very rarely do I ever use these types of loops. Okay? I'm going to show you the for loops that I usually use. I remember more than 15 years ago when I learned this the first time, I remember being like, I hate it. And I've hated it since. I don't know. Why? I don't know. I'm prejudiced against it like that. I don't know. I just hate it. All right, so it's very similar, same idea. So here's the regular for loop. So Python was the weird one. Now this should remind you of using range, but really when you think about it, the range in Python really was acting more like this. But that's what I'll call like the analogy here. So if I wanted to just have a loop run 10 times, I could say for I in range 10, right? And then this goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, here's how that you would write that syntax in Java. Yeah.
Is that basically not just a while loop with sunglasses on, though?
Yeah, they're all, yes,
Okay.
that's exactly correct. In fact, it's like an enhanced while loop specifically for like situations like this. Because what this says is for I, integer I, remember, if we've got I, we need the type, though, integer. So integer I, where is it starting? 0. Where is it going to? 10. At the end of the day, sure, you're like, OK, yeah, it's going to 10. Great, in the same way there. Really, the thing that needs to be in here is a Boolean expression. That's really it. So this is like the top of your while loop. And then here it's, OK, what do I do? OK, I finished running the loop once. Now what? Increment I by 1. Then run the code. You have a question?
Yes. If you did plus plus I, would it add the one before it prints it?
Plus plus I? No, it would still work normally. If you do plus plus I, if this was like years ago, there would be an advantage to that based on like the number of steps that the compiler or that the computer's actually going to take. Modern day compilers eliminate any pro or con over one or the other. But if you see plus plus I, it's probably someone trying to like show off that like, look how smart I am. I'm using plus plus I. But if you know enough, you go like, you're just being annoying. Yeah, yeah, yeah.
For the final I at the end of I plus plus, can that be any like integer?
Like here?
Yeah, can you change that to any amount you want to increment by?
Yeah, you could say plus equals 20. Yeah. I mean, this loop wouldn't run. It would run once, but you know. Yeah. Like this would also be like writing range. I should have included it. Maybe I shouldn't have. I don't know. Start at 0, go to 10, count by ones. But remember how like in Python range, like by default you start at 0. And by default you count by ones. Right? Yeah. Okay. The first one is just create I and where do we want to start? The second is the condition to check. Here we're using it just for like a counting for loop. So check if I is less than 10. And then what are we doing after each run of the for loop? Increment I. Overall, this says create an integer I and set it at 0. If I is less than 10, run the loop. Add 1 to I every time the loop runs. In other words, the loop will run 10 times. However, this is the same. These are functionally equivalent. Okay? Here's a for loop. Some initialization, some condition, some step. Okay? Loop stuff. Here, we initialize, condition, loop stuff, step. Now, you might say, well, if I'm just doing some like Boolean condition, like keep running while some sensor is reading like a red light or something. There's no step. You're right. But then you wouldn't be using like a counting for loop in that case. You use the tool for the job, right? This is show you like, oh, I've got like a counting for loop. I've got a counting while loop here. Same idea. Though that's not to say that like this condition can be whatever you want. It really is just a condition. Though most of the time you're seeing something like this. This is the common for loop that we use. Stuff like that. Cool? All right. So And above each loop is doing the same thing. Yeah, kind of be out. All right. In the for loop example, though, the initialized stuff only exists within the loop. So this is actually kind of neat. And it's actually kind of nice. If I have, let me show you. All right. When I hit run, nothing about what I see should surprise anybody. 0 through 9. Great. Right? Happy, sad. So when this loop's done, what value does I have? 10. You'd think that, but what value does it really have? Doesn't exist. And you're like, but it does. You just defined it. It only exists within the scope in which it was defined. It only exists in this loop. You go outside the loop, it's not there. And if you're like, well, that sucks. No. That's good. You don't want clutter variable if you don't need it. If you really want that I, you can do something like this, int I, and then do something like that, and it's fine. So now it's defined outside of the loop, which it can access it inside the loop and outside the loop. So if you really want to be able to access it after, fine, you can do that. But do you really want to? Probably not. It's kind of nice. Yeah.
So if it only exists within like that loop, does that mean that I could create a separate variable I outside of that loop and then have that I?
So you have to be careful. Let's play. Let's see what happens, right? So if I say int I equals 7, no, 77, and then print I. So is it actually even going to let me here? Yeah, it's already defined in the scope. So yeah. So here it's unhappy because as far as this one's concerned, it's like this can see everything outside the loop and inside the loop. So it's unhappy. But let's say you could. Do you want to? That sounds like a bad idea, right? Yeah, you're definitely going to just like ambiguity. No good. You don't want ambiguity. Okay. Some Java conventions. What I'm about to say is by no means exhaustive. There's a lot, okay? I'm just going to hit some of the big ones. 1, have only one public class per file. This is not a convention, this is a requirement. So I guess it's de facto convention, but like you have to, okay? Class names have to start with capital letters, like some class. Start with a capital letter. This is a convention. It's not required. You can make a class start with a lowercase, but Java police will come for you. So you don't want to do that. And this is a nice convention because whenever you go and create something, if you see it starts with an uppercase, you go, oh, it's an object. It's from a class. Nice. Cool. File names must have the same name as the class. So if I created a class called someClass, the file that it's saved in must be called someclass.java. That's not a convention, it's required. Function and method should use camel case, starting with a lower letter, a lowercase. Thank you. Some function, right? Variables should be camel case, starting with a lowercase, like some variable, some other variable. Great. And constants should use, like we learned, screaming snake case. Apparently that's what it's called officially. Is all uppercase with underscore separating words. That's called apparently screaming snake case, which I love. Static final int, whatever. This is a constant, right? And then any programmer sees a variable and screaming at them, they know it's a constant. Leave it alone. Cool? Now, you might say, well, hold on. We learned yesterday we can make final classes. Should all those be uppercase? Well, no. Think like, is it the constant or is it just something I want to make immutable? Because final was doing kind of like double duty there. Remember? We'll review this shortly. Yeah?
What's with the static?
Don't worry. It's not important really right now. It's just, you'll see. We'll have examples of this as we go. Okay, for next time. All right, if at any point you're thinking, how am I going to remember all these differences? You're going about programming all wrong. And what do I have here? What is this? Yeah, right? How am I going to remember how to do a for loop in Java? You don't. You Google and you go, oh, right? I've probably got billions of results within seconds. Look at these examples and you're like, oh, yeah. Eventually you do it enough, you'll remember, right? So that's not even a joke. It's such like a joke for programmers that it's not a joke. Like, this is how programmers work. How do I do this? I don't know, look it up. Figure it out. No one's psycho enough to memorize everything off the bat. Like, it doesn't work like that. Another way to get better is practice. Practice. It's the only way you're going to get better at this stuff, right? So, practice. Caddis is great. You can go back and do stuff we did in Python in Java just for the sake of, redoing it in a different language as an exercise of learning. You can look at Java code conventions too. That's kind of neat. You can go through this. Go read all a million pages of this, and you'll be all set. Cool? You're going to do that, right?
Yeah, I'll read all
Yep. Good job. All right. Questions now before we jump into reviewing objects. We're going to review objects from a Java perspective. Do I do any comparisons with Python? I might.
Yeah, I think so.
Let's see. Yes, I do a little bit of that. So, cool. We'll have some comparison there, so you'll have the context of Python while we talk about this. No questions? All right. So, we're going to define objects in a very similar way we do in Python. The differences are ultimately going to be like syntactical. Okay, it's going to be based on the syntax and some nuances that come up, but at the end of the day, it's going to be very similar. And the spirit of creating classes is the same way between the two languages. I mean, the only difference there would be like everything needs to be in a class in Java, where in Python it doesn't. But the spirit of what the purpose of the classes are is kind of the same, right? Let's make some objects. You can have classes full of static methods, fine. But a lot of what we're doing is making objects. So objects and classes. Objects are things that typically contain data and can do some action and can be acted on. They don't need to have data and they don't need to be able to do action. They can do one or the other or both. Sometimes it's kind of nice to keep these things separate, which we will do a lot of in this class. But when it comes to data structures, these things are kind of inextricably connected. Often when programming in Java, we're going to have several different types of objects interacting with each other. All objects have properties. We talked about these same things in Python, but we use like different names. But it's the same idea. It's the data associated with the class. Properties, this is the data. We call these fields. They're variables, but they belong to an instance. So like, you all in here have a first name. Okay? You all have a first name. So that would be like a property of you. You have a variable associated with you, the instance of your humanness, first name. The values will different. You all have different first names. Maybe some of you have the same, whatever. But you all have like different first names, but you all have names. And if I ask you your name versus you your name and versus you your name, I should expect different answers. And then the behaviors. This is like the functionality. What do the objects do? We call these methods. They are the functions, but remember, they belong to an instance of an object. They're instance methods. That would be like me telling you to raise your hand versus you to raise your hand versus you to raise your hand, right? The functionality is the same, but it acts on an instance. Okay? A class is where we define the object. Every object belongs to a class. It's like the blueprint for what does it mean to be a human, if I'm making a human class or something. So it defines what it means to be an object of that type. It's the code that says, it's the instructions. Here's how to go make an instance of an object. That's what it is. What type of object? Well, what's the class, right? Is it a car class? Is it a human class? Is it a course class? Is it a country class? Each one will have its own instructions for how to make that. For example, we could think of a human class with the fields first name and last name and methods eat and go to bed. Right? And one could make a Bob Smith an instance of a human class. The first name would be Bob, last name is Smith, and calling the method eat on Bob would tell the specific instance to eat. All objects of the same class have the same fields and behaviors, but the values can differ. There's no reason they have to be the same. They all have a first name, but they have different first names. If there's another instance for like Jane Doe, then their first name would be Jane. Okay? Objects of the same class have the same methods, but calling a method on one instance calls it on that instance. Right? If I tell you to eat versus you to eat, that's who I'm telling to eat. Not everyone needs to eat, only the one I tell to. But why? Well, classes and objects make abstraction a lot easier. Right? So how many of you know exactly how your HVAC system works? Probably not many of you. But how many of you have turned the heat up in your house? Right? So there's a lot of layers of abstraction between me and my thermostat and the actual HVAC system. And that's fine. Like, so all of those things are there. In fact, like, has anyone, I know the answer to this is no, but maybe it'll surprise me. Has anyone in here ever heard of like the essay called I, Pencil? It's a famous one. It's too bad. It's a good one. And the point of this essay is to go on, like, who here's ever seen a regular old like number 2 pencil, right? Of course, yes, like a pencil, a regular pencil, right? A yellow pencil. But the point of this essay is how like not a single one of you can make this. Because as soon as you go like, well, give me like the graphite and give me the wood and I can kind of, no, how do you get the graphite? How did the graphite get to you? How did you, like think of the total amount of work that actually goes into making a pencil. Who cut down the wood? Who got the gas for the chainsaw to cut down that wood? Who delivered the gas to the, like, we could play this game forever. Point is, something as stupid as a pencil, there's a lot involved. When I go, if you were to say, well, I'll just go buy some graphite and wood and stick it together. Okay, that's a high level of abstraction. A lot of work was involved in me going to buy that graphite. A lot of work was involved in me going to buy that wood. I've abstracted that out. I could just go buy that wood. But how did it get there? You could play that game forever. In the same way, we always play this game. Like, how do we make pasta, right? When you go make pasta, you probably think, I'm just going to go boil some water, throw it in, wait 10 minutes, and I'm good to go. You don't think about ion pumps in your brain. You don't think of like tendons contracting and your muscles moving. No, we don't do that, right? We deal with the world at different layers of abstraction. Another nice thing about objects is it allows us to encapsulate data and functionality like together, right? It's kind of like when we write a function like convert Celsius to Fahrenheit, we go, there we go. We like grouped that functionality together in the function Fahrenheit to Celsius, right? It's nice, great, we've collected it. An object is just like another layer of that where we can have a lot of functionality grouped together with some data. It's just more of that. It's like a more granularity with being able to have different layers of encapsulation and abstraction. So the high-level idea here is typically a class will consist of fields, methods, and a constructor. Though a constructor is just a method, it's a special method, but it's a method. So really it's only 2 things, but we just got to make sure we have the constructor. And I suppose we don't really need fields either, but anyways. And if we don't write a constructor, we get one. It's a whole thing. But that's typically what your classes have. In Java, class code is written in a file with the same name as the class, like we told you. So if I wanted to make a human class, I would create a human.java file, capital H human.java file. And then inside, I would say like public class human at the top. That's how I would do it. In this example here with the course class, see I've got course. I know you can't see that it's .java. It is. It's just hiding it from you. In fact, you can see it right there that it is. And then public final class course. The final is not necessary, but anyways. Public class course. Great. Cool? Cool. I'll come back to that. Okay, so I think it's best to do this stuff with an example. But before we get to the example, do we have any questions? All right. Contact list. We've been using the same general example since 161, since pretty well into 161. Remember how we made like a friends list or something, right? And then in lab, we did the same thing, but we called it something different. And then you create these objects, and then you create like a class that's effectively a list of those objects. And then we did that again in the assignment. And then we did that again in a lab. And then we did that again on the final. We're going to do it again right here. Okay? We're going to make some basic little class that's going to store some data. And then we're going to create a class that kind of manages that data for us. It's proprietary, it's designed for whatever we're making, but whatever. And this serves a purpose to like explain things. So maybe easier to learn with an example. So consider the following problem. There's a need to keep track of the names and email addresses of my friends. There's also a need to manage several friends' names and email addresses, right? So it's not just about keeping data from one or two people. I might have like a dozen or so people I need to keep track of. So, you know, I want some code to be able to do this. So what I could do is I'm going to make a class to represent a friend. And then I'm going to have another class that's going to be like my collection of friends. I'm going to call this my contact list class. I could call it friends, I guess, but that's, you know, too close to friend. And we're going to cover the contact list in a subsequent topic. I think it's not the next topic, but the next topic. Because the next topic is unit tests. So we'll get to it in data structures. All right. So a friend class. For this particular problem, we're going to keep it really simple. The only information the friend class needs to know is their first name, last name, and email address. That's it. We could play the game of adding all these other attributes or properties, whatever we want to call it, the fields. We could add a lot more, but it's not going to do us, there's no point to that, okay? The 3 will be sufficient. We're going to need a constructor to describe how to set up a friend. If you remember the constructor from Python, that was the special method that did all the setup work. Whenever we wanted to make an instance of a class, like instance of a friend, it defined, well, how do you do that? Like, the constructor by default, you didn't have to write any code to make, like, to let Python know, I need to go into RAM and set aside some RAM to create this object. That part's not what I'm talking about. What I'm talking about is like any like programmatic stuff that we want to do, like assign some attributes or something. We put that in the constructor. And yeah, we're going to assign these values to the fields. The behavior of the friend, we're going to be keeping it really simple. A way to retrieve information from the friend, a way to obtain a string representation of a friend, and a way to check if 2 friend objects are equal. This is pretty common stuff. If it seems like another one of these silly examples, this type of object is very common. So, you know, we get a lot of examples, a lot of experience with it. Questions, thoughts, concerns, comments. Remember, ask now. Don't wait for it to make sense. Make it make sense now. You have a question?
For the contact list, is that a catalog?
Like, it'll be like the equivalent to like the country catalog. Yeah, it's the same idea. And like, what did I call it on the exam? Like inventory of widgets or something, right? Like, it's the same thing, right? Wasn't I so nice on the exam? I gave you a question that was like exactly from the assignment, from the labs, and from the class. Wasn't that nice? I thought so. And if you didn't realize it was the same, man, come on. You probably, yeah. Anyways. So, where was I going? Okay, so setting fields and writing the constructor. So the constructor is a special method called to automatically, whenever we create an instance of the class, and it does all the setup for us. It sets up things related to the class. In general, we want our constructors to be very simple. If you find that you're writing a constructor that requires a lot of code, that's not necessarily wrong, but it would mean, like, do you really need that much code in there? Maybe you need to think about doing things a little bit differently, but that's a conversation for another day. In Python, the friend class's constructor and the creation and assigning fields worked like the following. Remember, in Python, self is used to refer to the instance of the class. And also, remember that, like, this is just to hedge against that asshole in the room that's always like, well, actually, this is not the constructor, it's the initializer. The constructor is technically something a little different, but it's not. So don't worry about that. It doesn't matter. We're calling it the constructor for our needs. And what is this doing? Well, first of all, we can see class friend colon. We're defining the class. Indent, def underscore underscore init underscore underscore. That's how we say constructor in Python. Open parenthesis, the first thing is self, followed by whatever we want in terms of the parameters. This constructor is very simple. All it does is it takes the values from the parameters and assigns them to the self first name. Why self first name? Well, that would be how we declare and assign the attributes, the fields for this class. This would be this instances. If I'm making an instance right now by saying, like, my friend equals friend, that one I'm creating, it's its first name, last name, email address. Okay? Here's how I do it in Java. Now, mind you, here I didn't have all like the Java docs in the Python one, but it's got the Java docs, whatever. Public final class friend. It doesn't need to be final. I'll talk about that shortly. Public class friend. We got to make it public. I mean, if we don't write public, it'll still work, but we make it public because if you don't write public, by default, it's package private, which is public within the package. It's the whole thing. Public class friend, open squiggle. All right? Now, these are the fields. I have to declare them. Remember, in Java, you need to declare a variable before you can use it, although you can declare and assign on the same line. Now, that won't really work for classes, so all of the attributes we want are defined outside any method. They're within the class, but not in a method. So I have 3 fields, first name, last name, and email. Their types are strings. They're final. More on that in a moment. And they're private. I don't want to be able to access them from elsewhere. We'll end here for now. We'll start here next time.